Welcome back. This is lesson 5-1, long division. In my 6th grade series, it's the first lesson in the 5th module. This should be a review lesson for you if you've gotten to this point. Long division is just the way we show division when dealing with larger numbers. It's a process that we go through, and we can divide to come to an answer. We're just going to take a look at a few examples of long division. I'm going to do a problem or an example. I ask you then to pause it and try the next couple on your own. Then I'll come back and work through the problem with you, and you can kind of check your work. And if you got something incorrect, you can then see where you made your mistake. So first, I guess let's take a look at an example. And this is the first example in your notes, so hopefully you have your notes out, the 5-1, and you're looking through this. Last year, a restaurant served 107,085 customers. It was open every day except Christmas and Thanksgiving. What was the average number of customers served each day? So first thing, we can show division in multiple ways. Okay, we can write it out as a division problem, like in this case, 107,085 divided by 363. Another way we can show it is through a fraction. I've said this multiple times, but a fraction bar is just another way to write a division problem. So we could have 107,085 divided by 363 that way. And then that would just tell me that I'm going to drop this into the house. And then the third way I could see it is with the actual division problem. Regardless of whatever way it's written, when we perform our long division, this is the way we want to set it up. So again, our first number in this problem goes in the house. Our second number goes out of the house. Our numerator in this scenario goes in the house. Our denominator goes out of the house. And either way, when you get the way you set it up or the way it's set up for you, your problem should look like this. Okay, so now we actually want to do the long division. I don't have a ton of room here, so I'm actually going to use this one. Hopefully you follow along. So I want to kind of just keep going from left to right until I have a number that 363 can divide into. Cannot divide into 1. You can put nothing there. I put an X there just to show that nothing goes there. Cannot go into 10. Cannot go into 107, but it can go into 1070. And I want to figure out how many times that it can go into 1070 without going over. In this case, if I wasn't sure, I would actually have to just start doing 363 times 3 and see what that is, or times 4 and see what that is, until I can get as close as possible without going over. Okay, because I've already done this problem, I know it only goes in 2 times without going over. And that 2 times 363, because I would have to actually do 363 times 2 is 726. So I want to subtract, because I do 2 times 363, and I get 726. And I want to subtract that amount. I cannot do 0 minus 6, so I have to borrow. 10 minus 6 is 4. 6 minus 2 is 4. Borrow from my 1. 10 minus 7 is 3. And then I want to bring the next number down. It's my next step when I do my long division. Now I want to see how many times 363 can go into 3,448. And it goes in 9 times. I do 9 times 363. Which is 3,267. I subtract. I have to borrow because I can't do 4 minus 6. 14 minus 6 is 8. 3 minus 2 is 1. 3 minus 3 is 0. So I don't have to write it down. Then I bring down my last 5. Okay, and 363 actually goes into 1,815 5 times, and it's actually even. So when I do my subtraction, I have no remainder, so I'm finished. This answer means that the average number of customers would be 295. 5 each day. And the reason why we did 363 instead of 365 is that it's not open only on 2 days. It's not open on Christmas and Thanksgiving, which would be 365 days. So you take away 2 and it's 363 days. That means that on average every day they serve 295 customers. Okay, pause the video, do the next couple long division problems on your own, come back, check the work with me. Hopefully you took a few seconds, you did these problems on your own. Okay, first one is 49,455 divided by 63. Remember, the first number goes in the house. It means 49,455 is in the house. 63 is out. Doesn't go into 4, doesn't go into 49, does go into 494. Okay, so I want to figure out 63 times what gets me as close as possible to 494. And I believe it's 7. 7 times 3 is 21. Carry my 2. 7 times 4 is 42. 2 more is 44. I subtract. I bring down my next number. Okay, it goes into 535 8 times. 8 times 3 is 24. Carry the 2. 48 plus 2 is 50. I subtract. I get 31 left. 315 goes in 5 times, and 5 times 63 happens to be 315. So my remainder is 0, and that means it goes in 785 times. Sorry, I don't really have a lot of room. I'm trying to fit it into a small space. Let's take a look at the next one. We have 858,661. Let me rewrite that. Give myself a little more space. Divided by 841. 841 goes into 858 one time. I subtract 841. I get 17 left, so I bring down my 6. 841 does not go into 176, so it's 0 times. And I bring down the next one. Now, 841 goes into 1,766 2 times. 841 times 2 is 1,682. I subtract. That's 4. Can't borrow. 16, 8. 84 is left. I bring down the 1. 841. So 841 goes to 841 one time. And my remainder is 0. So therefore, 858,661 divided by 841 is 1,600. I'm sorry, not 1,600. I can't read my own handwriting. 1,021. All right, but what happens if we get a problem where it doesn't go in exactly? Let's take a look at an example like that. So it says the Wildwood Crest Library is packing books for a move. They can fit 12 boxes in each box. 12 books, in each box. There are 1,976 books. How many boxes will they need? So I'm taking the number 1,976 and I'm dividing it by 12. And that is shown on my sample problem. My errors are horrible. There we go. Okay, I do my long division. Goes in one time. Bring down my 7. Goes into 77 6 times. 6 times 12 is 72. 56. 12 goes into 56 4 times. 48. And I have a remainder of 8. So now I have to look back at the question, because I could write this as 164 and 8/12, which simplifies 2/3. I could put a decimal point in, add a 0, and keep dividing and see if it goes in equally at any time. But in this case, I don't need to do either of those things, because the question is how many boxes will I need? Well, if I had 164 boxes, I would still have 8 books left over. So in order to fit fit those 8 books into another box, I would need to buy 165 boxes. So sometimes the question may ask you to either round up or down without specifically saying estimate your answer or round your answer. But because I have those 8 books left, I have to pack them into another box. That gives me 165 boxes. Okay, try the next 2 problems on your own. Come back, check your answers with the video. My first problem is just a fraction, 5,796 25ths. Again, we remember that a fraction bar is just another way to show division. So I want to do 5,796 divided by 25. I want to write that as a division problem. Goes into 57 twice. Subtract 50. Bring down my 9. Goes into 79 3 times. Subtract 75. Bring down my 6. Goes into 46 1 time. And I have 21 left over. So I'm going to write my answer as a mixed number, 231 and 21 25ths. Or you could bring down another 0, put in a decimal point. Goes into 210 4 times. I'm going to keep my mind going on over here. Minus 200. Bring down another 0. It goes into 25 4 times again. It's 8. My remainder is 0. So I could divide it out and also get 231.84. Remember we said that we could either keep dividing or we could write our answer as a mixed number. Unless they tell you otherwise, both are acceptable answers. Let's take a look at the second one. Jenny is splitting $1,444 amongst her 5 children. How much would each child get and what would be left over? So, again, when I'm trying to figure out which one goes in the house in a word problem, whatever is being split up, and in this case that is $1,444, that number goes in the house. It's being split up 5 ways, so that number is out of the house. Then I just divide. When I'm done dividing, they're each going to get $288 with $4 left over. Okay, that's long division. The only complicated thing difficult thing we have here is what to do if your number does not go in. If you have a remainder, sometimes you just need the remainder. In the case of the last word problem we did, they just wanted us to tell them what the remainder was. Sometimes you can leave it as a mixed number, or sometimes you can turn it into a decimal. Depends on what is asked, what you prefer doing. I like to have complete answers, so I like to divide it out until I'm with a decimal. If you have any problems with long division, please make sure you ask me. Leave a comment. If you don't have the notes, they're available in my Teacher Pay Teacher store. Do whatever you have to do.